All right, so now we're moving on to the slope of the regression line, because this is also something that is confused in a lot of people's minds. I want to explain what the slope of the regression line tells you and what it does not. Okay? So, you can see, first of all, that this is well, if we were to use like a skiing analogy, let's say you ski or you snowboard, this would be a fairly gentle slope, right? The slope is not very steep here. This would be the analogous to the baby hill or the bunny hill, whatever you want to call it. All right. So for beginners, this would be the hill you'd want to be on. Over here, if we look at the slope of the line, this is going to give you a much larger value. Here we're going to get a low value for the slope. This is going to be a much higher value for the slope. This would be the triple diamond. This would be the advanced slope. You would not put, somebody just starting off on this slope. They would probably kill themselves. So what does the slope of the line tell you? Well, it actually tells you how quickly the values in y are changing, how quickly they're going up or going down as we move along x. So as we move, let's just say we move 1 unit along x, okay? 1 unit along x. How much did y increase or decrease? Here, y is increasing. So when we move 1 unit along x, how much did y go up? And if the answer is it only went up by a little bit, and as you can see it would, let's say this is x equals 1. I don't know, this is x equals a half. So this is x equals 1, and if we were to predict y, this would be the predicted value. How much did it go up from here, where x equals 0, to here, x equals 1? It only increased a little tiny bit, right? But if you look over here, so again, here's x equals 0, x equals 1. How far did it increase, right? From the starting point, x equals 0 to x equals 1. Well, y increased by a lot more. See, the rate of increase here is much greater than here. All right, so if we were to measure the rate of increase here, it would be small. All right, when we move 1 unit on x, we only increase y by a little bit. Here, when we move 1 unit on x, we increase y by so much more. All right, so that's why I say up here, the slope of the regression line tells you how quickly or how much y increases or decreases with every change in x. So when you move 1 unit on x, how quickly do you see a change in y, or how big is that change in y? All right, so that's the slope. And if the slope is negative, then we would just say when we move 1 unit on x, how quickly does y decrease? Right? Okay, now there's another thing that the slope of the line tells you, and that's whether r is positive or negative. Because if the line is a positive slope, that means r is positive. And it's not shown here, but if we had a line with a negative slope, then that means r is negative. All right, so the slope of the line, we've just learned 2 things about it, right? One, you already knew. You knew that if the slope is negative, r is negative. If the slope is positive, r is positive. You already learned that. Now I added to that, it tells you how quickly y is changing. Every time you move 1 unit on x, how fast or how slow does y change? Now, there is some confusion, all right, or a myth. The myth is that the greater the slope, so the higher this value here, we give it a number, the higher the number, the larger the r value. And that is not always true, all right? And this is an example of when it wouldn't be true. So if we looked at this particular example, we see that there's a relatively gentle slope, right? But all the points are pretty close to the line. right? So here the R value would be fairly large. It's a gentle slope, but because there's not a lot of scatter around the line, the relationship is a very good one, and that would be reflected by a fairly large R value. Now here, the slope of the line is very steep, right? But look at these data points. They are scattered a lot more around the line than here, right? Here there's not a lot of scatter, here there is. So what did we learn about scatter and relationships? When there's a lot of scatter, your R value goes down. It means you have a weaker relationship. So here, even though we're going to get a very large value for our slope, our R value would be small, or at least smaller. So in other words, what I'm trying to point out is that you cannot reliably look at the value for the slope, right? Look at the number that gets calculated and say the higher the slope, or the higher this number, the higher the R value, all right? Because as you have seen here, that isn't always true. Now, the R value, you do learn something about the R value from the slope. And so let's look at that next, okay? So make sure you understand this, and now let's move on. The only time slope tells you something about the size of your R value is if there is no correlation between X and Y. If there's no correlation between X and Y, the slope will equal 0, or at least it'll be statistically equal to 0. There will be no slope if there's no correlation. All right, so let me say that again. There will be no slope, all right, if there's no correlation. So if you're told that the slope is 0 or something statistically equal to 0, so let's say slope is 0.08, and that's statistically equal to 0, then you know that the R value is close to 1. And that's the only time the slope can tell you anything about the correlation, right? As soon as we determine that the slope is not 0, okay, as soon as we know this, slope is not 0, then we know, okay, so R is not 0. That's what we know. R is not 0 when the slope is not 0. But does it tell us how big R is going to be? No. Because again, you can have a very, very large slope, a value here, a very high number, but the correlation is not necessarily high. Over here, you can have a very small value for our slope, and the correlation is actually quite strong. All right? So rewind this, listen to it over and over again until you get it, and write it out. Remember, the more and very different ways you try and learn information, the better and easier it gets.